Okay, so now we will start with the new topic of the truth table. So what is a truth table? It provides a list of every possible combination of the inputs and its corresponding outputs. Okay, so now if you look at this truth table, there are two functions, f1 and f2. If you look at f1 and f2, f1 is a function of how many variables? f1 and f2. Can you see here? So we have some set of inputs and outputs. So the inputs of the system are x and y. And what are the outputs? Outputs f1 and f2. So f1 is a function of two variables and f2 is also a function of two variables. So now if you look at f1, f1 is x dot y, and what is f2? X plus y. So if you look at the gate level implementation, so actually f1 is x dot y and f2 is x or y. Okay, so now this is the truth table for the f1, this is the truth table for f2. So it lists all of the possible combination of x and y. So x and y, how many inputs? Two inputs. How many possible combination? Four. Okay, three inputs. How many combinations? 8. 4 inputs? 16. Okay, so actually the truth table will cover all of the possible combinations of the input for each output. So if you look at the system, this system consists of two outputs, f1 and f2, and it consists of two inputs, x and y, and the truth table lists all of the possible combination of the input, which in this particular example are two inputs. So the two inputs, so there are 4 possible combination. If there are n inputs, how many possible combinations? 2 raised to power n combination. Okay, now if you look at here, now we have a truth table, and this truth table is derived from this equation. So now there is an equation, and now this is the truth table of this particular equation. So now if we say, now what is now the equation? Please can you let me know what is the equation? So now f is the equation. So f is equal to x plus y bar z. X plus y bar z. Okay. Now can we write something like this? X plus k. Now what is k? So k is now y bar z. Okay. Now if you look at this f is a function of 3 variables. F is a function of 3 variables. So what is f? F is a function of what? X, y, and z. So when f is a function of x, y, and z, so there are 3 variables. So now there are 3 variables. How many combination? So we have 2 raised to power 3 is equal to 8 combination. We have 2 raised to power 3, 8 combination. Okay, now if you look at here, f is equal to x plus k. So f is equal to x plus k. So which gate is this? X plus k, OR gate. So now we have an f which is the OR of x and k. So f will be 1. So can we write something like this, that f will be 1 if x is equal to 1, or k is equal to 1. Okay, or both are 1. Okay, now if f will be 1 if x is equal to 1, or now if you look at here x, y, and z, so now we have this x, y, and z. How many possible combinations are there? 8, 1, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 1, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So now this is your f. So f will be 1 if what is 1? X is equal to 1. When x is equal to 1? X is equal to 1 here. Can you see here? So when x is equal to 1, so now y will be f will be 1. Okay, now if you look at here, k will be 1, k will be 1. When k will be 1? K will be 1 if y is equal to 0, because there is a bar, and then z is equal to 1. Y is equal to 0 and z is equal to 1. Y is equal to 0 and z is equal to 1. Can you see here which combination is this? This combination and then this combination. Okay, so now in this case f will be 1 here and f will be 1 here, because both are 1. Now there is a 1 here. So now this is, and all of for these combination, for the remaining combination, the output is what? 0. The output is 0. So now this is a truth table. So now this is a truth table, this is the equation, and now if you look at here, this is the logic diagram. So if we have any function, so now we have a function. We have function. What is the name of this function? F. So this is the logic diagram for the function f. This one is the equation of the function f, and this one is the truth table of the function f. Any question? Should we proceed? All clear? All clear. So if you look at here, now we have some color coding. Please concentrate. We have some color. What is the color coding for x? Right. So the output will be 1 if x is equal to 1. So now this is x is equal to 1 when x is equal to 1. Got it? And then the output will be 1 when y is 0 and z is 1. So y is 0, so this is blue color. So now these are the color combinations for this. So Boolean equation and describe the same function. Okay, now if you look at here, now we want to derive, this is the truth table. So how many possible combination? 8 combination. So this one is f1 and this one is f2. How do, okay, now we have derived this f1. If you look at this example, f1 is a function of how many inputs? 2 inputs. And f2 is a function of how many inputs? 3 inputs. Okay, so can you see here x dot y plus z, x dot y plus z. So x dot, so the output will be 1 when x is equal to 1, or either y is 1 or z is 1. Okay, now if you look at here, y plus z. So f1 will be 1 if y is 1 or z is 1. So y is 1 or z is 1? Where y is 1 and z 1? This one, this one, this one, this one, this one, and this one. Can you see the red and the blue thingy in this column? What is red? For red, y is 1, and for blue, z is equal to 1. Got it? And now in this case, both y are 1 and z is 1. So it means y is also 1 and z is 1. So the red color indicates the combination for which y is 1, and the blue color indicates the combination for which z is 1. So now this is the truth table for f1. And now if you look at it, what is f2? f2 is the product of x dot y plus z. So now we also have y plus z, we also got it, but it's the product of x. So can you see here in all of these combinations, what is this? X is 0. When x is 0, the output is what? 0. Okay, and in this case, when x is equal to 1, output is y plus z. So when x is equal to 1, output is y plus z, which is actually 0, 1, 1, 1. Got it? So now can we see here for f2, the output is 0 when x is 0, and the output is y plus z when x is equal to 1. Got it? When x is equal to 1, this is the output. So 0, 1, 1, 1. Got it? Any question? Should we proceed? So now this is the truth table. And how can we prove something using truth table? Okay, now if you want to prove that x dot y plus z, which law is this? X dot y plus z is equal to x dot y plus x dot z. Which law is this? Distributive law. This is distributive law. Okay, now so we are having the product of x dot y plus x dot z. Okay, now if you look at here, so we need to compute different tables. We need to compute this. And how do we prove that these two are same? So now we can do it now. We have x, y, and z. How many combination for x, y, and z? 8 combination. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So these are 8 possible combinations. Okay. So now what we need? y plus z. When this y plus z will be 1, either of these is 1. So I'm just, we are just, so now this y plus z, 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 and y plus z. These are red circle. So either y is 1 or z is 1. So this is 1, 1, 1, 1, 1, 1, and for the remaining, 0. All done, clear. Okay, now we have x dot y. When the output will be 1, both of them are. So I'm taking this with tick. So both x is 1 and y 1, because this is an AND. When x is 1 and y is 1, which combination? Last two. So now this is the, so now last two, they are 1 and all of them are 0. 1, 2, 3, 4, 5, 6, 7, 8. Got it? Okay, now x dot z, when it will be 1? X and z, when x and z are 1. So I can use the red, this. So x dot z, here, and then last one, these two. So now in this case, here it will be 1, and now it's here it will be 1, and all of the remaining combinations is what? 0. And then x dot y plus x dot z. Okay, now we want to prove it that x dot y, which column is this? This column, plus x dot z. We are having an OR of them. This is f1, and this one is f2, and what is this? f1 plus f2. This is in which gate? OR gate. So 0 0 0 0 0 0 0 0 0 0 0 0 0 0 1 1 1 0 1 1 1 1. Okay, and then so now we want to prove x dot y plus x dot z, and we want to prove that x dot y plus z. Where is x dot y plus z? Oh, we didn't compute it. X dot y plus z. Where is y plus z? This column. So now this is what is this? f3, and this is x. So now we want to multiply x with what? f3. So now this is f3. So x with f3, 0 0 0 0 1 0 0 1 0 0 1 0 1 0 0 1 1 1 1 1 1 1 1. Now we have proved that this is equal to this. So now this is how, when we want to prove something, we can prove something using a truth table. So now can you see in the first blue? The first blue is what? The left hand side or right hand side? The left hand side. And the second blue is the right hand side. Okay. So now this is a proof using truth table. In a truth table, we cover all of the possible combination of the input. And what are these? The three different inputs. And what are these inputs? X, Y, and Z. And all of these possible combination are 8. So now if you look at here, f1, when f1 will be 1? No, f1, x is 1, y is 1, z is 0, the red one. Second thing, okay, when f2 will be 1? When x is equal to 1. When these, for all these, it will be 1. And then y is 0 and z is 1. Y is 0, z is 1, and y is 0, z is 1. So can you see here? 1, 2, 3, 4, 5. Good. And when f3 will be 1? f3. What about f3? So now we want to compute f3. What is f3? Yes, please help me. f3 z plus x y bar. Okay, x bar, y bar, z bar, 0 0 0. So this is term number 1, 0 0 0. So I'm using it red, 0 0 0. So now this is red 1 1. Okay, now we have the second term. I'm making it in green. Which combination? 0 1 1. Where is 0 1 1? 0 1 1. So this one is the green one. Now we have the third term. In the third term, this is red, and now we can make it black. So x is 1 and y is 0. X is 1 and y is 0. X is 1 and y is 0. This one. And x is 1 and y is 0. This one. Got it? And then this one is not here. Oh yeah, in the black one it's 1. Which one is 1? Yes, these are ones. So we have 0 0 0. No, this one is not here. 1 1 1. Yes. So actually, can you see here 1? So it is 1, then 0 0 0 and 0. And similarly, you can make this for F4. So this is your homework. Okay. Okay. Now, if you look at here, now we have given a circuit. Now we have given a circuit. So some circuit is given. How many inputs for this circuit? Can you see how many inputs? 3. How many outputs? 2. So these are 3 inputs and 2 outputs. Function may be expressed as a Boolean function, or it can be expressed as a truth table. So now we have a design. Given the desired function, determinate circuit, or the function may be expressed as a Boolean function or a truth table. So now, what is this? The logical diagram. This is the logical diagram. Okay. How many inputs? 3. What are the name of these inputs? A, B, C. How many outputs? 2. What are the name? F1 and F2. Okay. How do we derive this expression? Now we have T2. T2 is what? ABC. It's the end of all these 3. What is T1? A plus B plus C. Why A plus B plus C? OR gate. What is this? F2. AB. Let's assume this is K1, K2, and K3. AB plus AC plus BC. Okay. Now, if you look at here, now we are complementing this, the whole thing. So this is F2 bar. So this is F2. This is F2 bar. And F2 bar is actually, if you take the De Morgan's theorem, so this is AB plus AC bar. So now, can you see F2 bar? So F2 bar is equal to AB plus AC plus BC whole bar. And if you apply the De Morgan's theorem, what is this? A bar plus B bar dot A bar plus C bar dot B bar plus C bar. Got it? And then if you look at how T3, so T3 is actually the AND of T1 and F2 bar. So and if we solve this, so this becomes it. After solving. So you need to solve it. Okay? And then now this is F1. So F1 is this and F2 is this. Okay, now how do we analyze the truth table? How many combinations are there for truth table? 8. So we apply all these combinations. What's the first combination? 0 0 0. So if you apply all these combinations, all the outputs are 0 0. So 0 0 0 and it's 0 and 0 or 0 is 0. Now can you see it? 0 it becomes what? 1. And then it's 0, it becomes 0. So that is a function. And then you apply the next combination. We apply to all of the possible combination, and then we find F1 and F0. Then we apply the other combination, all these. Okay. So what is, how can we derive a truth table? We can apply all of the possible combination to a particular logic diagram, and then we can derive the output variables. And what are the output variables in this example? F1 and F2. Got it? So now we go through all of these possible combination, and then okay. Now this is a task. Please use the truth table to prove the following. You can use the truth table. Okay. Now if you see here, and now this is important, because this is important. And maybe this is very simple, but this is important. Okay. Now use the truth table. We have which function? A and B. How many possible combination? 4, 0 0, then 0 1, then 1 0, and then 1 1. Okay. Now we want to find A bar and then B bar. What is A bar? A bar. May you please help me? What is A bar? Now the guy with the cap. Yes. 1, then 1, then 0 0. Very good. And B bar? 0 1 0. Very good. So now we have A bar B bar. Okay, now we want to compute A bar B bar. So this is the AND of both. This is 1, this is 0, this is 0, and this is 0. And then we have what? A B bar. A B bar, which column? A B bar 0 1. A B bar 0. A B bar. A B bar. So this is 1. If you look A B bar 1 0 done and all these zeros. And then when what we do here, A B to 0 0 0 1, and then A plus B bar. What is A plus B bar? A plus B bar. A plus B bar 0 1 1 0 0 0 1 1 1 1 1 1. So now we have proved, and now we want to prove this what? And the sum of all. Can you see here? Sum of all. A bar B bar plus A B bar plus A B. So now we want to find this K. K is the OR of these three. 1 0 0 OR 1 0 0 0 0 0 1 0 1 1. So now we have proved that this K is equal to A plus B bar. Okay, now if you look at this expression, so now this is K. What is K? Please look at here. K. What is K now? A bar dot A bar B bar plus A B bar is A B. And what is K? And this, what is L? A plus B bar. So now we have proved that. So this is K and this is L. We have proved that K is equal to L. But now look at the implementation of K. So in K we need how many AND gates? 3 AND gates. So for K, how many gates? And how many OR gates? 1 OR gate. No, 1 OR gate. Because the first term, the second term, the third term. So this one is K. So this one is K1, K2, and K3. This one is K1, K2, and then K3. And then we need how many inverters? We need 2 inverters. One for A, one for B bar. So now we have A bar, B bar. What is the second term? A B bar, and then A B. And now we use 2 inverter, one for A and one for B. Now we have this another expression, A plus B bar. So now we have an OR gate. The first input is A, and the second input is what? B. So the first implementation requires how many gates? 3 AND gates, 2 inverters, and 1 OR gate. And in the second implementation, we need 2 input OR gate, which is reduced. So 3 input OR gate has more delay than the 2 input OR gate. The more number of inputs, the more will be the delay. Okay, so now which implementation is better? This implementation is better, or this implementation is better? This implementation. So this is called as the reduced expression, and this is the unreduced expression. Unreduced or expanded expression. Got it? So now if you want to, so now you use the truth table. So now if you look at here, and you look at the second term, B, in B. If you look at the second term, which one is the reduced one? On the left hand side or right hand side? Right hand side is the reduced one. Okay, for this, how many gates do you need? 2 AND gate, 1 OR gate, 1 inverter. But in this case, and 2 input OR gate. 2 input OR gate. In this case, 1 2 3 1 3 input OR gate. How many AND gates? 3 AND gates of how many inputs? 3 inputs each. And how many inverters? No, 2 inverters. Because 1 for A and 1 for C. For B, we don't need an inverter. Think? So that's the reason that we want to reduce. So our objective is to reduce the expression. And how do we reduce the expression? We will use Karnaugh maps. And before explaining Karnaugh maps, we need some definition. And these definitions are very important. Please, and remember, this session is very important. I need your concentration here. Okay, duality principle. We know the duality principle. Which principle is this? distributive, and now we also have the duality. You also know that. We also have this. Okay, x plus y plus z whole bar is what? X bar dot which theorem? De Morgan's theorem. X dot y dot z whole bar, x bar plus y bar plus z bar. Got it? Boolean function. So Boolean function is an expression formed with the binary variables. Binary, what is the binary operator? And, or, and not. And now we have the truth table. We explained it. What's a function? The complement of a function. The complement of a function is the opposite. So we use an inverter to complement a function. Got it? So now we have the function. It's complemented. If let's say if the function is x, y, z bar whole bar. So what is this? X bar plus y bar plus z. Because z double bar, then it becomes z. Got it? So now this is the De Morgan's theorem. So these definitions are very important. These definitions, please, you need to learn all these definitions. Complement. What is a complement of a function? So if we have some variable, so now we have Boolean variable. We can have any Boolean variable. So in this example, we can have variable a, we have variable b, then we have variable l, we have variable k. So what is a complement of a variable? It's a bar over it. It means we have any variable and we use an inverter to convert it. So a bar is a complement, b bar complement, l bar complement, j bar complement. Now we have another definition, literal. Literal is a variable or its complement. So a bar is a literal, a is a literal. Is a complement? No. A is not a complement, but a bar is a complement. A bar, is a bar a literal? Yes. Okay. So any variable, and it should be a single variable. Implicant. It's very important. Implicant. It's a product end of literals. It's a product end of literal. A, B, C is a literal. A bar C is a literal. A, C bar literal. Huh? Implicant. It's an implicant. It's a product end of literals. Now what is a literal? Literal can either be a variable or its complement. Literal can either be a variable or its complement. Got it? Okay. Now there is a difference between, and you know, some people are very confused with this implicant and the min term. So product and that includes all input variables. What is an implicant? So the product and that includes all its variables, and it's very important. Now it depends on the number of the variables. Okay, now if you look at, if you have some function, a, b, c, any function, and we can have any function. Now if you look at here, this function, how many variables? 3. There are 3 variables. Okay, for this 3 variable, a, b bar is an implicant. Okay, a, b bar, c bar is an implicant, but a, b bar is not a min term. Why it is not a min term? Because it excludes c. Okay, now again, if we say AC bar, what is AC bar? Implicant. Is it a min term? It's not a min term. It's not a min term. Why it is not a min term? Because B is not included. Yes, please. Yes. Every min term is an implicant, but not every implicant is a min term. Okay, now please, some people are confused with something. Some people. Let's now in this example, we are assumed that we are considering a function of 3 variables. Now assume that we have another scenario that we want to have a function of 4 variables. K, L, M, and N. K, L, M, and N. How many variables are there? 4. So if you say K, L, M bar, it's a implicant. Got it? K, L, and M bar is an implicant. Can we say K bar, L bar, M bar, and N bar? min term and implicant. Why KLM bar is not a min term? It is not a min term. Why it is not a min term? Because it is missing n. Got it? Any question? Should we proceed further? So now there is a difference between implicant and okay. So now if we have a function of 5 variables, if we have a function of 5 variables, so the min term will require 5 literals. Min term will require 5 literals. So by definition, so we can say, so if we have a function, so if we have a function of n inputs, so the min term will require how many literals? N literals, or the max term. So sorry, not the max term. Implicant. The implicant will require from what? Not 1. From 2 to n. 2 to n literal. Because you know it's a pro. And if it's 1, it's a literal. Because then it's not an implicant. So you need to know that definition. We need to know definition. So okay. Now if we say K, L, M, and N bar. K is a literal. L bar is a literal. K and L bar is not an implicant. K, L, N bar is an implicant. K bar, L bar, M, N bar, min term and implicant. So these are all the possible combinations. So in the exam, I may also give you a table, and I can say, okay, what is this? So you can say, okay, is it a literal? It can be literal, it can be an implement, it can be both, or you can. So you can also have, yes, please. Which one? So A dot A times A bar, A dot A bar, it's a constant, it's 0. And that is a constant, that's not a literal. So if you say, you're good. So you say A dot A bar, it's a constant, 0. Got it or not got it? And then if you say A plus A bar, 1, so it's a constant. And if you say A dot A, it is reduced to A, it's a literal. You got it? I hope I answered your question. Should we proceed? Good. So now, because these definitions are very important, for all of the concept, because we will be finding a reduced expression using the sum of product terms, and then we will be using complement, literal, implicant, and min term. You will use all of these terms. Okay. Now, what is a max term? What is a max term? So max term is the sum that includes all the input variable. So and all input variables. So a max term, it is the OR. So A plus B bar plus C is a max term. Okay, for this function, K plus L bar plus M plus N bar is a max term. So max term must include all input variables. Got it? So min term should include all the input variables, and max term should include all the input variables. But what's the difference between max term and min term? The first one is the and the second one is the OR. OR of what? OR of all literals. Okay, if we have a function, so we can say if we have a function of n inputs, so a min term is the product term of n literals, and if it's a function of n inputs, so the max term is the sum of n literals, and n literals, and each literal can either be the variable or its complement. Definition is done. Should we proceed now? Good. So in general, n variables can give truths for n min terms in a similar fashion. A max term of n variables is the sum of all literals. So I will explain this with an example. And please, I will ask some student to help me in like generating some table. So for the sake of simplicity, I start with a very small table for the sake of simplicity. So now we have some variable a and b. A and B. How a possible combination? 0 0 0 1 1 0 1 1. Okay. Okay. Now we call this as minterm mi. We call as mi. Okay. Now in this case, so if we convert this into decimal, what is this? 0, then 1, then 2, then 3. Okay. Now we have some minterm. So minterm is it includes all literals. So what should it be? M1 M0 because it's 0. M0 is what? A bar B bar because it's A bar B bar. May you please help me? What will be M1? Yes, please. What will be A1? M1? No. M0 is A bar B bar. Why? Because we have 0 here and 0 here. A bar B bar. Then what is M1? Very good. You are taking interest. Thank you very much. And then we can say, can you help me again? What is M2? AB bar. Very good. And what is M3? AB. So can you see? So now we have what's this? This small m stand for minterm. This small m stand for minterm. Yes, please.
This number after the m, which is the I, what does it represent? The decimal?
So this is the decimal. Yes, this is the decimal.
We should represent decimals like it.
Yeah, this is 0, 1, 2, 3. Yeah. So if we have two variables, so we will range from 0 to 3. If we have three variables, 0 to 7. If we have four variables, 0 to 15. If we have five variables, 0 to 31. So can we see? So now I can say. So now we have So now we have n is 2. So we have a max. So we have a total of. So we have a total of tours for n minterms. We have a total of tours for n minterms. So in this example, we have 2. N is now 2. Tours for 2. How many minterms? 4 minterms. Okay. So it ranged from. So it ranged from M0. 0 is the first one. To M3. So this is M in general. M0 to M2 n minus 1. Because what is the range? So the range is from 0 to 2 raised for n minus 1. N is 2. So now 0 to 2 raised for 2 minus 1 is actually 0 to 3. Got it? Any question? Should we proceed? Okay. Now we have called for the minterms. Minterm. So minterm is the product term or the sum term? Product term. Okay. Now this is M0. So now we have the capital. Capital stands for max term. So we have then when what? M0, then M1, then M2, and then M3. And please help me. Please, anyone will help me. Okay. Now, if you look at the max term, so the max term is the plus. So we have a plus here. Plus, and the plus, and this is actually what? A plus B. For 0, we have A, and for 1, we have A bar. Okay, A plus B. Please help me. Can you please, now for M1, what will be M1? A, very good, plus B bar. And then, what is M2? This is 1, A bar, very good, plus B. And what about M3? A bar plus A bar. So that's A bar plus B bar. Why it is a max term? Because we have a plus here. So now if you look at here, so each min term is the dual of the max term. So this is A bar B bar. So this min term is actually Mi bar. Got it or not got it? So this max term, so this, can you see, Mi is the dual of, and vice versa. So if you say this M0, so now this M0 is the complement of M0. And what is this? What is M0? A bar, B bar, and then whole bar. This is what? Double bar plus B double bar. This is what? A plus B. Got it? So this is very important. This is very important. So now in general, if we have a function of n inputs, if we have a function of n inputs, how many max term can we have? 2 to the power n. How many minterms can we have? 2 to the power n. Okay, so the minterm will start from 0 to 2 to the power n minus 1. Similarly, the max term will start from 0 to 10 to the power n minus 1. Got it? So the minterm is represented by the small m, and max term is represented by capital M. And the minterm is the dual, or so the minterm is the complement of the max term, and the max term is the complement of minterm. Got it? Any question? Because these are very basic definition. These are very deficient. So now we have a function of two variables. What are these? No. Minterm or max term? Max term. What? Max term. 0, 0, 0, 1, 1, 0, 1, 1. This is 0, 0, 0, 1. This is inverse. Yes, please.
I don't understand how you got the max term.
No problem. A and B. 0, A. 0, B. 0, A. 1, B bar. For 1 we convert.
Why not A bar plus B?
It's not. I will explain. There is a reason for this. Please, when we will be going to solve it, so when we will using the sum of product expression and the product of sum expression, I will explain this point at that point, not now.
So now
just memorize this. Whenever you want to calculate the max term, so you when you have a 0, you put the variable as it is. If it's 1, then you complement it. Got it? So this is actually, can you see here? It is 0, 0. So this is what? 0, 0. For 0, 0, what? A plus B. This is 0, 1. A plus B bar.
And the min term is the opposite.
It's the opposite, yes. But min term is the product and max term is the sum. Just for at this point of time, because we will be using this min term and max term in the sum of product expression and the product of sum expression. But if I explain the product of sum expression and sum of product expression now, you will be confused. But I don't want to confuse you at this point of time. I don't want to confuse you at this time. So when we will be going these expression and why we are using min term, why we are using max term, there is a logical reason behind it. And I will explain you this reason. I will come to that topics. Got it? Okay. Now, so if we have, so now in this example we did it something like this. Okay. Now again, so if we expand this function. If we expand this function to 3 variable function, so if we have a 3 variable function, for instance a, b and c, so we have a 3 variable function a, b and c. How many combination will be there for a, b, c? Yes, please. 8. So this one will be what? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So now it will stand for what? 4, 5, 6, and 7. So what will be the min term? Okay, now can you see? I can directly write A, B, C, 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 A, B, C. Again, you know, if you want to solve some question in exam, so do it something like this: A, B, C, A, B, C. Okay, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Got it? Okay, now these are the min term. This one is what? M0, M0, M1, M2, M3, M4. Okay, now can you help me in the first one? What is this term? Yes, please. Can you help me? The max term, not the min term. Yes. A bar plus B, C bar. And then you can do so. So this is a plus B plus C, A plus B plus C. Now we can do, let's on, we can go A plus B plus C. The markers are not working good. A plus B plus C, 1, 2, 3, 4, 1, 2, 3, 4, A plus B plus C, A plus B plus C, and A plus B plus C. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1. Got it? So in a 1 we have, yes, please. Yes, the output should be 0. Yes, you're right. For max term, the output is 0, because if the output will be 0 if all of them are 0. So 0, 0, 0, the output is 0. Yes, you're very right. So for the main term, the output will be 1, and for the max term, the output will be 0. Because why? If we say 0 plus 0 plus 0, the output is 0. And for min term, if it's 0, 0, 0, and you invert it, 1 dot 1 dot 1, it will become 1. So for the min term, the output will be what? 1. And for the main term, the output is 0 for that particular combination. Yes, please. What? Yes, it's a part of definition, and we will use this min term in the sum of product expression and max term in the product of sum expression. No, no, for each particular row, can you see? For each particular row, this is what? A bar plus B bar plus C bar. So A bar is what? 1 bar plus 1 bar plus 1 bar, and all of them are what? 0.
For example, you are asking us a question: is this a minter? Is this a max up? If it has all the variables,
Yes.
but the output it's not 0, it's 1.
No, no, so actually each min term. So you can say now if you have any function, let's assume this is a function. I got your point. I got your point. This function is A, B, and C. A, B, and C. Okay, so it's a variable of how many inputs? 3 inputs. How many combination? 8 combination. But you don't know its value at runtime. It can be 0, 0, 0. It can be 0, 0, 1. It can be 0, 1, 0. It can be 0, 1, 1. So the function, so this output will be 0 for this input, but its output will be 1 for other inputs. So for the main term, so this is very important. So I will give so the for the main term for this particular combination, the output will be 1. For all of the other combination, the output will be 0. For this particular combination, so I will explain this. Okay, I will explain this, and then maybe you get my point. Now assume that we have the combination is 0, 0, 1. 0, 0, 1. So M1 will be 1 because it's 0, 0, 1. This will be 1, and all of them will be what? 0. Got it? Why? Because if it says 0, 0, 1, 0, it will become 1, it will become 1, and it will become what? 0. This 0. So for the main term, for that particular combination, the output will be 1, and for all of the other combination, the output will be 0. And for the max term, for a particular combination, the output will be 0, and for all of the other combination, the output will be 1. Why? Why it is 0? Because this main term is actually a product term, and a product term says if any input is 0, the output is 0. And for the max term, it's represented by what? OR gate. And if any input is 1, the output is 1. Got it? Please wait for some time, then I will say that how it works. Wait for some time, and then I'll explain it. So min term is, you got it or not got it? This function of how many variables? 2 variables, x bar, y bar, and these are. So this notation is what? Main term notation, M0, M1, M2, and M3. Which notation is? Max term. Got it? Now We have a function of how many variables? 3 variables. We have a function of 3 variables, and the minterms contains how many variables? Literals. 3 literals. Each minterm contain 3 literals. Each maxterm contain 3 literals. If you look at here the pattern, now we have a pattern. So should I rub this off? Where is the duster? Let's assume we have a function of A, B, C, and D. A, B, C, and D. Okay. Now A, B, C, and D. So now we have, let's assume 1, 1, 0, 0. 1, 1, 0, 0. Can you see here? So this is 1. Remember again 1. Then what? 2. Then what? 4. Then 8. It's equal to what? 8 plus 4. 12. So we need to compute M12. M12 is small m. Min term or max term? Min term. How can we write it? A, B, C bar, D bar. How can we write max term? M12 capital. A bar plus B bar plus D. Okay, now assume 21. 21. How can we write it? 21. 21 cannot be represented. Why 21 cannot be represented? Because if it's a function of 4 variables, now it's a function of 4 variables. If it's a function of 4 variables, it will range from 0 to what? 15. Remember? So you please, I may also ask these kind of tricky questions. So if you say, so 21 does not exist. So if you say M6, how can we achieve 6? 0, 1, 1, 0. Why? 4 plus 2, 6. Okay, now what will be M6? A bar, C, D bar. What will be M capital 6? Plus D. Got it? Okay, now we have another 15. 1, 1, 1, 1. It's a 15. What is M15? And what is capital M15? So these are the min terms and these are the max terms. Got it? Okay, now should I rub this off? So I will now answer your question. I will answer your question. And for the sake of this simplicity, I'm taking a function of 2 variables. What is the function of 2 variables? A and B. A and B. 0, 0, 0, 1, 1, 0, and 1, 1. What is Mi? The min term. A bar, B bar. Then AB, AB, AB. 0, 1, 1, 0, 1, 1. Mi. Yes, please. Okay, 0, 0, 0, 1, 1, 0, 1, 1. Got it? Okay, now please, how many combinations do we have? At least 4. Okay, now can we write, so now this, what is this? M0, M1, M2, M3, capital M. And now we have M1, M2, M3, and M4. Got it? Okay, now we draw a truth table. So that this truth table is something like this. So now we have A and B, Now we have M0, M1, M2 and M3. What are M0, M1, M2 and 3? Minterms. Then we have M1, capital M, capital M2, capital M3 and capital M4. Which one? Oh, it also start from 0. M0, M1, very good. M2 and M3. You know, you're intelligent now. You become intelligent now. You are also catching my errors. Okay. So now we have 0, 0. When we have 0, 0, so M0 is what? 0, 0. It will become what? 1. And all of the other minterms will what? 0. And if we have 0, 1, then 0, 1, 0, 0. If we have 1, 0, what will it become? What will be the output? 0, 0, 1, 0. And then 1, 1, 0, 0, 0, 1. So can you see for any minterm? So you can say only this M0 is 1 and all of the remaining are 0. You got it or not got it? Okay. Now, if you look at here for the max term, okay. So now this is actually A plus B. This is an OR gate. A plus B. The first max term is A plus B. So A plus B. So this is actually A plus B. What is this? A plus B bar. So now if you look at here, A plus B, 0 plus 0, 0. And then A plus B bar will become 1. When it become 1, it's an OR gate. It will become 1, 1, 1, 1. And what will be the pattern? 1, 0, 1, 1. Then 1, 1, 0, 1. And then 1, 1, 1, 0. So if you look at here, so for any combination input, so now only there is 1 0 which is in a particular row. So for each, so you got my point or not? So for each particular combination, for that particular combination of a row, for a minterm, the entry will be what? For a particular combination, the entry will be 1 and all other 0. So if can you see, so now can you see here, this is actually, so now we have, so now what is the index now? So now the index here is 0, the index is 1, the index is 2, the index is 3. So for any index I, so now any index I, so can we say, because I'm writing in a very generalized expression, for any, so I can generalize this, for any index I, for any index I, mi is equal to 1, and for all other indexes, and this is other than I, so mj is equal to 0, where j is not equal to I, and j belongs to the set of 0 to 1 and 2 until 2n minus 1. Got it? And okay, so for any index I, mi is 1. Okay, so can we say for any index I, mi, which is the main term index, is 1, and for any index I, the max term m, the capital M I, is what? 0. And for any other index mj is what? 1, where j is not equal to I. So now this is a generalized expression for a min term and the max term covering all of the possible combinations. Got it? So now, so in this particular example, so for this, so can you say for m0, when I0, so m0 is 1 and all other are 1. Sorry, is 1 and all other are 0. And capital M is 0 and all other are 1. Any question? Should we proceed? You miss? I'm a twinkle, twinkle, little star. You know, it's a very good sleepy song. Okay. Any question? So if you look at here, what will be the min term here? What will be the min term? What's 1101? A, B, C bar, D. And what will be the maximum? A bar plus B bar C plus D bar. Got it? So now you know how to convert into momentum. Got it? Now we have another definition, because I'm not giving a lot of definition at this point of time, because sometimes you will be confused. So now we have a canonical form which is called as the sum of the min term. So the canonical form, it is the sum of the min terms. So what is the canonical form? It's a unique form for representing something, and min term of product term. Min term of product term. And what is a min term? Min term is the product of how many literals? N literals, when we have any function of n inputs. Got it? So now we have this f1, f2, and f3. Okay. Can you see here f1? Can you see f1? So we say sigma m6. Why sigma m6? Because this is what 110, and 110 is the code for what? 6. 110. 4 plus 2, 6. Okay. Can you see f2? Can you see in f1? Can you see in the green? In the green, 0, 1, 2, 3, 4, 5, 6. So f1 has a min term of 6. What about f2? Which min term are high? 1, then 4, 5, 6, and 7. 1, 4, 5, 6, and 7. What about f3? Look at f3. 1, 3, 4, 5. This is called as the sum of the product term. Okay, I need your attention here. I need your attention here, and then I will give you some example, and then you will help me in solving this problem. Should I rub this off? This is understood? Good. Okay, now we proceed further. Now we assume that we have a function of f, a, b, and c, a, b, and c, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. And now this is our f. Okay, now we also write the indices in decimal. What is the index? 0, 1, 2, 3, 4, 5, 6, and 7. So if you say 0, 0, 1, 1, 0, 1, 0, 1. So now this is f1. What is f1? f1 is the sum of all min terms. Which min term? 2, 2, then 3, then 5, then 7. Got it? Okay, so now we can also say, so now this, if you look at here, so if it is the sum of all min terms, so now 2, please look at the particular row, 2. How can I write it? 2, a bar, b, c bar. Okay, 0, 1, 0, plus 3. Oh, so ABC plus ABC plus ABC. Okay, 0, 1, 0. So this is what? 0, 1, 0. What about the second one? 0, 1, 1. 0, 1, 1. How will it become? A bar BC. And then look at this 5. 5, 1, 0, 1. B bar. And then the last entry 1, 1, 1. Got it? So if you look at here, so now this F1 contains how many ones? 4 ones. So since it contains 4 ones, it contains how many min terms? 4 min terms. So the number of ones corresponds to a min term, and the number of 0 correspond to max term. So this expression, okay, now if you look at here, F3, in F3, how many ones are there? 4 ones. F3. What are these ones? 1, 3, 4, and 5. And how can we derive this F3? Now this F3 is equal to X bar, Y bar, Z. Then this one, x bar plus x bar y and z. Now this term plus x y bar z bar plus x y bar z. You got it? So now we have, okay, now we, how many functions do we have? Three functions. We have three functions, which is f1, f2 and f3. F1 contain, okay, please I ask you a question. How many minterms are contained in f1? One. Very good. How many minterms are contained in f3? No, f3. 4. How many minterms are contained in f2? 5. Very good. So now these are all the minterms, and now, so now, okay, now we have two representation. We have two representation. Now, is there any gate level representation? We don't have gate level representation yet. Okay, so now we have two representation. One representation is the truth table. One representation is the truth table. So this is the truth table representation of three functions, f1, f2 and f3. Each of these function is a function of how many variables? Three variables, which is x, y and z. So look at the black box. Now we have a black box. In this black box has three inputs. What are these inputs? X, y and z. It has three outputs. What are these outputs? f1, f2 and f3. So now we have three inputs and three outputs. So now we have three inputs and three outputs, and this black box, now this black box is represented by the truth table, and according to this truth table, f1 is a function, has contained how many minterms? One minterm. F2 contains 5 and f3 contains 4 minterms. So now these are the minterms. So this is one representation. So now now this is a truth table representation. This one is more concise, or this minterm representation is more concise. Concise. If you say f sigma 6. Now yeah, can you see here sigma m6? Can you see here? So now you say sigma x m6. So it means now we have only represented this in, instead of building the truth table, we have, so this one is more concise representation of any Boolean function, and this is a sum of product term. Okay. Now if you look at here, the sum of product term. So now we have some function. Now this function f, this function f contains how many minterms? 5 minterms. It contains 5 minterms. It consists 5 minterms. Okay, now it contains 5 minterms. What are those minterms? A bar, B, C. Why? Because 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. And each of the minterm correspond to a particular row in the truth table. Each of the minterm correspond to a particular row in the truth table, which is representing a logical 1 or a logical 0? Logical 1. So for, if we want to represent in sum, so in the sum of product term, please again, the sum of product is the sum of all minterms. It corresponds to all the entries of the truth table which represent logical. Got it? And then how do we, so if there is a 0, if there is a 0, so it is represented by a complement or the variable? 0. In any entry has a 0, it is represented by its complement. So let's assume 0 represented by its complement, and 1 the same variable without in complement with the same variable. So 0 is represented by anything. Okay, now each row in the truth table has a minterm. A minterm is the product end of literals, and we know what is a literal. Each minterm is true for that row only. Each minterm is true for that, and then we prove it in the previous case. Remember? Only. So if let's assume if this is 1 for this combination, this entry will be 1, and all of the combination will be 0. All Boolean equation can be written in soft form. Can you see here? So now let's assume we have this combination 101. For 101, which entry will be 1? This entry will be 1. So for 101, this input will be 1 and all of the other inputs will be what? 0. No other product will turn on because why they will be 0. So if we say 101, 101, so A bar. So A, if we invert A bar, because this is an AND, it will become 0. Now if you look at here, 101, okay, A is 1, 0 is 1, but C is 1. But C is 1 because it's bar, then it becomes 0. You got it? So for this particular combination, this term will be 1 and the other term will be zeros. Got it? And we explained it in the previous slide. So this is called as a standard notation. So if you okay, so now for this representation, remember the order of the variable is very important. If you say A, B, and C, A, B, and C, so A is the MSB and C is the LSB. If you say CBA, C is now the MSB and A is the LSB. So please, the order is very important because if you say 0, 0, 0, if you wrote in the reverse order 0, 0, 0 and then 0, 0, 1, so it means that the whole notation will change. So when we say we agree on the order of the variable, so the order of the variable is very important. So then we can enumerate each row with the decimal number that corresponds to the binary number by. So in this particular example, what is the MSB? A. What is LSB? C. If we change it CBA, then C becomes the MSB and A becomes the LSB. So the order of variable is important because for the order of variable we can determine the equivalent decimal number. For this particular order, so this is equal to 0, then 1, then 2, then 3, then 4, and because this notation is important, because whenever we have some notation, it's important. It's all for today. Thank you very much.